In this video, we're going to be looking at simplifying trig functions. So we want to simplify the expression. And what I mean by that is we want to get it down to one function. So I'll write that note. Down to one function. And how we're going to do that is we're going to use our trig identities to substitute other values in here so that we can get it just down to one trig function. So like just down to sine, tangent, and so on. So number one, I have tangent of pi over 2 minus theta times sine of theta. Well, I see this tangent pi over 2 minus theta. I know that was one of my identities. So going back up here, I see that tangent of pi over 2 minus theta was equal to cotangent of theta. So that means I can replace this tangent of pi over 2 minus theta with cotangent of theta. So I see it's a little bit simpler. And then I know from up here, for cotangent of theta, I also had another value. I see that cotangent of theta is equal to cosine of theta divided by sine of theta. So this becomes cosine of theta over sine of theta times sine of theta. Well, when I multiply across now, I have cosine of theta, sine of theta divided by sine of theta. So I see that my sines of thetas cancel out, and so I'm left with just cosine of theta. And that would be my simplified expression. Let's try another one. So here I have secant times tangent squared of theta plus secant of theta. So there's a couple different ways that we can look at this. First, what draws me is the fact that tangent is squared. And I remember from up in my identities that I have a tangent squared here. So I'm going to go ahead and solve this for tangent squared. And when you do, you end up with tangent squared of theta is equal to secant squared of theta minus 1. So I want to replace tangent squared of theta with that value. And so I get that this is equal to secant of theta times secant squared of theta minus 1 plus secant of theta. So I see everything's in secant form now, but I'm going to go ahead and distribute that secant theta to see if we can get this to be an even simpler expression. So I'm going to distribute secant of theta, and when I do that, secant of theta times secant squared of theta, I get secant cubed of theta minus secant of theta plus secant of theta. And then I see that my secants cancel out here. I have minus secant of theta plus secant of theta, so those cancel out to 0, and I'm left with secant cubed of theta. Okay, let's try 2 more. So here I have cosine of theta minus cosine of theta times sine squared of theta. Again, I'm drawn to that square because I know I have a Pythagorean identity. So solving this for sine squared of theta, I just subtract cosine squared of theta from both sides, and I'm left with that sine squared of theta is equal to 1 minus cosine squared of theta. So I want to simplify that in. And so I have cosine of theta minus cosine of theta times 1 minus cosine squared of theta. So now I have everything in terms of cosine, but just like with secant, I want to go ahead and distribute to see if I can simplify even further. And so when I distribute, I get cosine of theta minus cosine of theta plus cosine cubed of theta. And so again, I see that my cosine of thetas cancel out, and I'm left with cosine cubed of theta. Okay, let's look at one more. So here I have tangent of x times cosecant of x over secant of x. So here I have 3 different trig functions, and for each of these, we have a different value for those. So first I see with tangent, I know that's sine of theta over cosine of theta. I know that cosecant is 1 over sine of theta, and secant is 1 over cosine of theta. So I want to go ahead and substitute in all of those values. And so tangent, I know is sine of x over cosine of x. Cosecant is 1 over sine of x, all over secant, which is 1 over cosine of x. So for a lot of these simplifying, you're just plugging in identities and seeing what helps you simplify the expression. So multiplying across on the top, I have sine of x over cosine of x, sine of x, all divided by 1 over cosine of x. And so here I see that my sine of x cancel. So I'm left with 1 over cosine of x divided by 1 over cosine of x, which is equivalent to 1 over cosine of x times cosine of x over 1, which I find to be equal to 1.